Okay, hello and welcome to today's webinar. Thank you for joining us. I'll just be introducing the webinar with a few housekeeping rules while our participants are joining. So again, welcome. This is the second webinar in the FlexSNG series. Today, we're going to hear from Erik and Anders. Before I introduce the two of them, I would like to just inform you all about the housekeeping rules. So you'll see at the bottom of your screen, or I think it's at the bottom of your screen, a question and answers box. If you have any questions and answers, any questions for our presenters, please write it in the question and answers box, and then it will be answered either written form or spoken form at the end of the presentation. You may, of course, use the chat box, but we'd like to keep the chat box just for exactly how you're using it, to say hello and welcome. Please do not ask your questions in this box because they might get lost or not answered. Okay, so without further ado, I'll introduce our two speakers today and the theme of today's webinar. So those of you who've been following FlexSNG or any other types of syngas technology, you might realize that the supply chains are in general more challenging and complex than other supply chains for other feedstocks and products. So that's where Erik and Anders have stepped in, and in FlexSNG, their research is focusing on how to create an optimization tool and advanced decision support systems to help cope with these challenges. And eventually, we hope to deliver a competitive, low-cost feedstock based on local sustainable waste and residue streams. So without further ado, I'll hand over to our first presenter today, Anders, who is going to tell you a bit more about exactly this. So, hi, Anders. Welcome to the screen. The floor is yours.
Thank you for the introduction, Emma. The title of this webinar is Flexible and Integrated Biomass Value Chains. It is organized, as Emma mentioned, within the FlexSNG project, the Horizon 2020 project. In this webinar, Creative Optimization and Skogforsk will share some common challenges that one faces in almost every bioenergy project when we talk about raw material and feedstock supply. We will discuss how these challenges can be met and addressed. We will discuss a data-driven approach to address the challenges, but we will also discuss how synergies can be used to cope with the challenges that we present for bioenergy supply or bio-based material supply for bioenergy projects.
Thank you, Anders. We can't see your screen if you're sharing your slides.
Yeah. No screen at the moment.
We can just see you talking.
Ah, wow. I can try to reshare the screen.
Yes, please. Okay, yes, now we can see it. If you just put it in full screen and perfect. Okay, yes.
Is it in full screen now?
Now we can see and hear you perfectly and the screen.
Perfect.
Okay, great.
Perfect. So after we have discussed the synergies that one can see to address the common challenges that we see in everyday raw material supply, we'll go into how advanced decision support system can be used to realizing more of the bioenergy project, since cutting costs within the raw materials or feedstock supply is really crucial to make a profitable project. And we'll discuss how complex logistic puzzles can be solved with mathematical modeling. So that is basically the approach. And I will start this session. My name is Anders Eriksson. I'm a researcher at Skogforsk. I will after that hand over to Erik Rönnqvist, COO of Creative Optimization. And as mentioned, it will be two parts. First, the challenges and the identified synergies, and then hand over to Erik, who will discuss how these findings can be incorporated into advanced decision support systems. And After those two parts, we will open up for a common discussion and a question session afterwards. So that is the structure of the webinar. Just an introduction of the FlexSNG project to those who are not familiar with it. It's about flexible production of SNG and biochar via gasification of biomass and waste feedstocks. Basically, we want to develop and validate a flexible and cost-effective gasification-based process for production of pipeline quality biomethane, high-value biochar, and of course, renewable heat. And we want to do this from a quite broad variety of low-cost biomass feedstocks from the agricultural sector, from the forestry sector, but also from the society. And in general, the project focuses on cutting capex in the investment, optimizing the process within the gasification. It's about a flexible approach to which kind of products that you produce, directed towards the market situation. But this webinar will focus on the first part of the value chain, how to source and supply the material in a cost-efficient way. The project aims to cut feedstock supply cost with 20%. So we will discuss ways to realize this cost reduction. So first, a few words about Skogforsk. It is the Forestry Research Institute of Sweden, working with applied research, mostly forestry applications, of course. Our vision of Skogforsk is a world-class forestry for sustainable development. Our mission at Skogforsk is to develop and communicate knowledge, services, and products that promote sustainable development in forestry, of course, for benefit of the society. So that is the core mission of Skogforsk, for those who are not familiar with Skogforsk. Okay, from waste to value. Throughout history, we have seen how different residue streams from the agricultural sector, from the forestry sector, and also from the society has found ways to an industry application, different ways to add value to different projects. But we also have seen a trend to find the best application, the most high value application for each of those. And it is quite challenging. All of them have quite individual characteristics in terms of how we handle them, in terms of which quality that we see within these streams. And we also know that they have a lot of variations between them and within them. But the key is basically to see what do we get, how do we maximize value from those. When we discuss common challenges for bio-based feedstocks, it is really crucial to bear in mind that many bioenergy projects, it can be decisive for failure or success if we handle the logistics and the feedstock cost in a smart way. It is not easy to work with, but if we are smart, we can still deliver a low-cost material with sufficient quality for the specific application at hand. And in general, many of those are dispersed in low concentrations. This is definitely not a mining industry where you have a resource at one spot and you can design your logistic systems around this resource. Here we have the resource everywhere in the landscape. We almost every time we are quite far away from the market. When we talk about bio-based feedstocks, we often have storage problems. We have dry matter losses. The material degrades with time. So when you have stored the material for half a year or a year, you will end up with less material, probably worse quality. We also know that we have a low and varied quality. We can have challenges with ash content. We have a varied moisture content, the calorific value, of course. We also have a bulky material, difficult to transport, low energy content. And this is not standardized either. We have a lot of variations and heterogeneity that we need to cope with as well when we want to design specific feedstock streams for specific applications, especially if they are demanding applications. Some applications are more robust and can take almost any feedstock. Some have more demanding specs that we need to cope with in the supply system. And also we need to be aware of the handling aspects, the form and the fractions. This is not a liquid that is easily handleable. We can pump it and so on. This is challenging in a handling perspective as well. And when we talk about bio-based material for the heating sector, we have a really cyclic demand with high peaks in the wintertime, low peak in the summertime. So we need to have a system that can be scaled up during a few months and then scaled down, which is also challenging, especially for the ones that work within the systems. I will use logging residue in the Nordic countries as an example to discuss how to cope with the challenges. For those of you who are not familiar with logging residues, these are top and branches that arise when we cut down a tree. So we can see in the top left figure, we have the material, the logging residue heaps spread across the clear cutting area. We need to move the material, but before we move it to a roadside, we often let the material dry out for some time, let the needles and nutrients stay at the clear cut area. But we need to take the material afterwards to a roadside landing where the material is accessible for trucks. So we take out the material, we typically store the material for some 6 to 18 months, both to let the material dry, but also to pair up with the industry demand, which is in the heating season, the winter season. Due to the low bulk density, we process and ship the material before transport, increases the transport properties. We can take the material directly to the end user, but we can also take it to a terminal. We can work with increased quality, as you see in the middle picture and the bottom of this one. We can screen and sieve the material for premium fractions. We can also work with more coarse fraction, find different applications for those. We can use a secondary transport with train, for example, if we want to go for regional or markets more far away. And of course, finally, we end up with the fuel delivery. And as you can see, it is quite complex. There's a lot of processes. There's a lot of people working within this. And even though it seems easy now, it's a straightforward flow. We have different ways to process the material. We have different ways to transport the material. We have multiple alternatives possible. And to do this in a cost-efficient way, smart logistics is really, really required. And we need to be efficient in every single step of this. And we also need to be aware of that it's not a bulk material. Of course, the amount matters, but also the quality matters. So we need to have that in mind also when we set up our logistics system. So furthermore, if we zoom into the FlexSNG projects and discuss challenges in the supply chain of bioenergy assortments. Of course, we have the agricultural sector and the residue streams arising from the agricultural sector and the agro-industry sector. We also have the forest industry, which create the byproducts, and we also have primary byproducts as logging residues. And also the societal sector as well. All of those have individual challenges, and one way to add synergies is to what if the combination of those can help cope with some of the challenges. That has been a hypothesis within this FlexSNG project, that there is synergies that can be utilized in a smart logistics system. Of course, we have a specific demand. We want to produce biomethane, we want to produce biochar and heat. For the agro-industry, we have the seasonal availability, really is seasonal. We have the variations in properties, in energy content, mode of transport, price efficiency, moisture levels needs to be on track of. For forestry, when and where to process is key issues. We discuss transport mode. Should it be railway? Should it be boat? Should it be truck? What kind of truck? Quality is an important issue. Resource allocation, price efficiency, and also different inventory levels need to be kept in mind. For the waste fractions from the society, when to process, availability, limitations in inventory, cost efficiency. Of course, if we have a challenging feedstock, quality for the gasifier will be important as well to keep in mind. Of course, it's not only about feedstock and delivering the best material. Some of the quality factors can be compensated for. We can, for example, discuss different drying processes. We can discuss smart inventory usage, yield in relation to feedstock, seasonal variation, competitiveness. We are not, the FlexSNG application are not the only one that want bio-based feedstock. We can also discuss, should the feedstock be handled in separate campaigns? Could it be valuable to mix certain feedstocks to reduce, or the more challenging feedstocks can be mixed with a more easy handling feedstock and thereby add value? If we zoom out a bit and discuss synergies to a more efficient supply, one can see the complementary effects. If we see feedstock supply and we see FlexSNG as a part of a larger industry landscape, we know that the heating sector had a specific demand pattern throughout the year. For example, if we can open up for fuel delivery and during the summertime, that could complement the heating sector in a really nice way. We can, for the actors working with delivering logging residues, for example, that is a perfect opening if we can deliver material during summertime. But we can also discuss complementary effects with individual feedstocks that complement each other. We can, as we see in the top left picture, we can work with central storage points and terminals. We can merge different biostreams. We can mix and tailor them towards different applications. We can gain logistic advantages by changing transport mode, for example. Some of these feedstocks, the forest, the agro, and the societal waste feedstock streams can be in really small concentrations, and individually they are too small, but if they are handled in coordinated routes, can be profitable to handle them if we do this in a smart way, in a sequence of pick applications. Quality is an important issue. If we discuss moisture content, for example, we can try to deliver the best material at the best point, delivering the right material at the right time. And of course, some of the industrial applications have really narrow quality specs. Some have a really broad quality specs. So it's about delivering the material when it adds the most value. We can combine the forest and the agro biomass delivery in a sort of yearly production or delivery plan. We can do this in smart ways. Of course, we cannot mix and blend material in any composition, but sometimes it could be handled in specific campaigns, or it could be mixed throughout the year. Information and collaboration is really also crucial for synergies. If we can share information within the sectors, but also across sectors, a lot of increased efficiency can be achieved. Third one, so we can see in the bottom left picture here, is sharing of resources. In the agricultural sector, some of the machines are quite expensive, capex-wise, but they are only used for a quite short period of the year. So sharing of resources can also be an important way to add synergies within this system. I will end up with showing examples of how to use information to add a new perspective of how to set up your supply, going towards more tailored supply where each material is directed to the best customer. We know that in this graph we see the moisture content variations throughout the years. We know that the material tends to be more wet in the wintertime, tends to be more dry in the summertime. Of course, we can use these seasonal fluctuations, but we also know that we have like a geographical fluctuation as well. And of course, individual fluctuations. Even though we are in the wintertime, some of the logging residue piles will be drier, some will be wetter. So it's really an important factor to deliver the best material at its best point. We have the geographical variation as well, as we can see in this time series map. We have like a west-east gradient, where in general in Sweden, it rains most on the west coast, which results in wetter material in general. The east coast is less rainy. We can deliver a drier material from the east coast, but of course we have the individual variations and the variations due to storage time as well. We can develop more precise grids of moisture content variation, trying to understand which is the crucial factors for a drier material or a wetter material, which kind of data can highlight which kind of material that we can expect. Another example of how cooperation, coordination, and information can help to take more smart logistic choice is those two aspects. Here we see two different companies, a green company and a purple company. In the left picture, they have a couple of supply points. They have a supply responsibility to different industries. If they want to do this individually without cooperation, we will end up in the left picture. But in some cases, there are a lot of efficiencies to be gained system-wise if these two actors, the green actor and the purple actor, cooperate and try to see which materials should be delivered to which industry. And maybe the purple one can deliver some of the responsibilities that the green has, and instead the green one delivers some of the responsibilities that the purple one has. Then we can, by sharing of information and using the synergies and cooperation, increase efficiency. So this is just a brief introduction to the challenges that we see, different ways of adding information. And now I will hand over to Erik, who will discuss how this has been implemented in decision support systems. So thank you for me, and over to Erik.
Well, thank you for that introduction, Anders. It's really interesting, and I do emphasize on sort of the key challenges with different aspects of the feedstock. I'll talk a bit more about the supply chain as well, and some of the challenges that we have to cope with, but I think you bring it up that all these feedstocks are very different. We cannot see it as a individualistic or responsible for one part. It's really a mix of different stuff that works in different ways and can convert in different assortments. So just to give you a brief background, I'm from Creative Optimization. We are specialized in optimization tools and sort of how to use optimization and decision support systems within the value chain and logistics, mainly focusing on forestry today, but sort of trying to bridge the gap between both research and industry applications and the use of them. So that's sort of our base premise. I'll not talk more about that. If you are interested, you can talk to me more about that later as well. Sort of to start with discussing it, it's sort of why are we using decision support system and optimization? We have to bring these to a scope. And we really begin with why do we use it? Yes, so we try to sort of enable the use of digital twins. We try to see the value chain from a digital perspective, trying to create a form that we can sort of plan with, and we can simulate, and we can try to find, you know, the optimal planning for real conditions, trying to lift real conditions into actual need, and sort of a digital space where we can actually utilize the tools and sort of the data that is available, and getting better by better every year. And sort of the idea of that is sort of trying to integrate the planning. So we want to integrate the planning with sort of different business units. We want to sort of incorporate, you have, for example, in forestry, you have the logging sort of production, forest production, harvesting, then you have the transportation and logistics, then you sort of have the industry where they're doing the production, and then you have the sales, which are doing the sales in the background. So you have a full value chain of different sort of planning's perspective. And what we try to do is really to incorporate that in together, trying to integrate these different planning stages from silos to doing a full value chain perspective, having, you know, that company overview, sort of trying to find what is the optimal decisions for the value chain management to sort of optimize the overall net income for the full value chain, instead of looking at individual silos. So that's the premise on really why are we using optimization, and why are we using decision support systems? So in context with sort of what Anders was going through, and a bit sort of a reminder of what are the challenges in the sort of the FlexSNG problem. So we start with sort of the idea of the FlexSNG process as a biorefinery. So we sort of can see we have the biorefinery here. We have forest residues. So we know that there is forest residues. We know there are agriculture residues. Then, of course, we also have the municipality solid waste, which can only go one way. So we have that located. But as we can imagine, that can be centralized from different hubs as well. So there's, of course, a complete value chain within municipality solid waste as well. Then, of course, we can also set it nearby to sort of a permanent industry that is already there, like a pulp mill or a sawmill, that we can sort of incorporate with, you know, the byproducts. So you would have ships coming from a sawmill that we can incorporate into the biochain and feedstock process. But then, of course, we sort of have the forest residue and the agricultural residues as well. And then we can see that, well, we can transport it directly to our mill with sort of a truck, which can be quite long distances. Either it can be short or it can be longer. So that's why we sort of have to incorporate into this problem. We have to incorporate we have a terminal where we can utilize train, for example. So now we can transport that to the train or the terminal train, and then we can transport that to the mill. So we add that as a complex decision. Of course, then it's the same for agricultural waste. We can either incorporate that into a terminal, doing it by train or by truck from a terminal, but we can transport it directly as well. And because this is so complex, we also have, you know, we can import it. If we're on a coastal line, we can import this product from sea as well. So there's all of these different kind of complexities that we have to solve. So as a basis to this product, when we began the FlexSNG program, we used a tool called Woodflow and Bioflow, where we started out. So its purpose and the tool already sort of in the beginning existed in an easy format where we streamline the logistics and try to find, you know, how can we solve this logistics problem, this linear programming solution, sort of the network problem. How do we solve that? So we began with that, and sort of that tool is already being used in an operational, tactical, and a strategical level. And where we begin sort of is looking at, well, we do decisions on purchasing, procurement, storage, delivery, and sales. And the key components in that for us was really trying to figure out how do we do the network? How do we find the distances with the truck? How do we find the distances with the train? How do we find the cost? Then, of course, how do we model it? And then how do we solve it with an optimization? So we use that as a basis, looking into FlexSNG, where we now had new problems. Not only did we have to solve the networking problem that we had solved before, but we also had to incorporate the processes. So how do we handle the feedstock in terms of transportation and processing? Because we can change the feedstock in different stages. We also have to take into account the quality and the moisture level count throughout the year, as Anders mentioned about the seasons. And of course, we also had to take into account sort of the processing for the biorefinery, because they can do flexible production. They can use different kind of feedstocks. How do we incorporate that into sort of recipes and campaigns over a period of time? And as well, of course, the co-handle capacity and joint value chains. So we did have to add quite a lot of challenges into this as well, going into it. So starting with the transportation and the processing, as an example here, we want to know, when do we do what decision? So Anders showed you sort of the example of forest residues, which would be, we have forest residues that needs to be converted into ships, and ships needs to be used by the biorefinery in the end. So we start by the decision is really the question, should I ship it here? Should I ship it at roadside storage or at the municipality solid station? Should I transport it bulk to a terminal and ship it at the terminal? Or should I transport the bulk and do the shipping at the actual biorefinery, which then opens up, of course, a direct stream. You don't have to use the terminal. So how did we solve this kind of decision? It was really the trick of, how can we convert one assortment into the other? So we had to start with sort of forest residues. So we defined that with truck type, what soil moisture count does it have? What quality is it? Sort of by dry ton or by energy. At what time period is it available? At what time period did we harvest it? And of course, what's the price to buy it and what's the cost to actually procure it? Understanding the processing cost in this process. Then as well, we had to take this into account. So wood chips, what kind of transportation modes can we use with wood chips? Now we open up possibly train. We open up new truck types. We open up the potential of having storage capacity. We have the terminal utilization and sort of the train connections overall. And we include this, that now we have a selection of choice. So we either ship it at forest roadside storage or we ship it at the actual terminal. And of course, we include cost here as well, because it's a cost in handling the material either coming into the terminal or going away from the terminal. So there's also an inventory cost dilemma that we have to take into account here, which we've done. And then, of course, in the end, we have sort of the demand, quality allocation, moisture count level, and then also the drying, inventory levels, cost. And of course, something that we have to include, which is very important, is the sort of the end product price. So we have this complete value chain problem with the processing. So what we've done is that we've actually defined up so you can do different processing at different nodes throughout the entire network. So we know we can follow the product. We can start with forest residues, but we can end up with the end product, which would be syngas or biochar, because we can convert it through time all the way. Another thing that Anders mentioned was sort of the seasonal variation and effects on the feedstock. So we look at sort of the quality and moisture level. We look at the availability in seasons, and we can know that the seasons is different. So we had to take that into account. We had to sort of find a way to understand how do we model different conditions. Sort of an example would be Sweden. Spring and summer arrives differently in Sweden. You would have it quite early in the south, but in the north, it would come much later. So we have to take that into account, understanding that season can be defined on different geography levels. And how do we follow moisture levels, like Anders showed on the map? How do we follow that over time? So that's a big sort of dilemma that we had. And what we did is that we found a way to sort of follow the feedstock through time periods. So let's say I define it by month or I define it by weeks. We can follow the feedstock throughout these time periods and follow the moisture level as we go through the season. So taking as an example, we see this line, we see forest residue. So we have a moisture count that we can follow. This is the forest pile that is laying on the road all year round. So this, no new harvesting. So this is just by the road. It's been drying for a while, and this is the curve. It will follow naturally throughout the year. It will be dry during summer. It would be more moisture count during winter. So what we define is sort of how do we gain into this curve? So when we harvest, we can see sort of the yellow line here. We start by doing natural drying. So we begin this processing on natural drying. But when you hit the curve, sort of following by time period, we know the soil, well, the moisture count of the feedstock over time. And this has been a great sort of leverage in understanding how the moisture count sort of affects the quality over time as well, because we can keep a track on this specific pile as we go along. As well as something that we had to add, which is quite dependent on the project within FlexSNG, is also, so of course, the sort of the drying at facility. So we add energy to lower the moisture count, hiring the quality by energy value. So we add sort of a process that, of course, has a higher cost than natural drying, because that's for free. But we add sort of a cost and sort of a boundary that we can lower the moisture count if we add energy and sort of convert our assortment at either a terminal or at a biorefinery to lower the moisture count. And this has been quite a success in the modeling perspective. Sort of the end part where we look at sort of, now we've done, you know, the transportation, we've done the conversion, we've done the moisture. Now we have to take into account, as I mentioned before, it's sort of the dilemma of the production. So what combinations can be achieved? How can we sort of link these different feedstocks together? Because they don't all mix. Sort of as Anders went through earlier, we have different quality aspect. We have some of them are not suitable to be together because they sort of create a higher sort of a problem with the gasifier, making more sort of dirt and inefficiencies in the system in that regard. So we have to to sort of carefully think about how can we access them together, and how do we create these kind of recipes with forest residue, agriculture residues, and sort of a deep dive into the assortments itself. So how do we solve this? That's a problem that we had. And as well as, what do we want to produce? Do we want to do one thing, or do we want to do another thing? Do we want to produce just heat, energy, or do we do syngas or biochar? This kind of problem, linking those two together, because now we have an inbound flow and we have an outbound flow, but we don't know really what's the most efficient, and we want to be sure to maximize the profit in terms of this is what we want to produce. So how we solved that was that we created a way of defining recipes percentage-wise. So we can define sort of a recipe that we have. Recipe 1 in this example is just forestry residues. Then we have recipe 2, which would be forest and agri waste. And then we have recipe 3, which would be forest, agri, and wood waste. And we can combine these in different percentage perspectives. So we can have, you can fill up to a certain amount of percentage as a factor to sort of create these recipes, and taking that into account. And what we're really doing then is that we're letting the model sort of decide, how do I want to select these recipes, taking into account the drying processing, the moisture count of the product that I enter into the biorefiner, the storage, the availability over time periods, sort of understanding what is my production sequence. So it could be that I do forest and agri waste during summer or in fall, because I have an abundance of agri waste from that sector. So I can use that directly when it's sort of a dry, or I want to let it dry, and I wait and I do perhaps just a forest residue in the beginning. So I can really see the production schedule and the campaigns over time, letting the model really find what is the most optimal one in terms of cost of the supply, the storage capacity, and the availability over all the time periods that I'm looking and planning for. So coming back, rounding, these challenges that we saw and that we've solved in terms of the modeling perspective, we can now look at sort of an example using decision support systems, DSS, as a scenario analysis tool and a due diligence tool. So what we have to take some things into question, and some things that we have to keep in mind in really utilizing these kind of tools and optimization as we go along. It's really, how can we evaluate sort of the location? So for instance, I could place one location here, or I can place another location much more north. Now I want to sort of compare these two, and I take that into account. Sort of, what is the feedstock availability? So I have perhaps forest residues, I have some municipality solid waste, I have some agri waste. And for the north one, I only have forest residues, but I have a more abundance of volume closer nearby. And what we want to take into account when we have these availability maps is that we really have to think again and sort of include, what are the transportation modes that I have sort of in leverage that I can use? Can I use trains? Can I use sort of a harbor if I'm nearby a coastal line? Can I do sort of collaborative logistics in this area because we have more companies in the south? Or do I keep in the north because I'm individualistic? Or can I collaborate with new partners in the north to lower the price? As well as, what are the processing and pre-treatment availabilities and opportunities in my specific regions? What can I do as a production recipe? We can see in this example in the north, we only have forest residues, but in the south, we can sort of combine it with solid waste, and we can combine it with agri waste as well as forest residues. So I have to take these things into account. But another thing that you'll normally forget when you do these sort of scenario analysis is, but what is the competitiveness in this area? So we have to take that into account, that, for example, in Sweden, we have a high abundance of need of bioenergy, which we use for forest residues. So we have to take that into account, that we can actually have to compete with other companies. So this is an example where we can see that we have a sort of a cost figure of distance. So we only see the distance, sort of understanding what's the cost as we go along the road network. And we can see sort of the highlight purple one could be a competitor. And we can see that that competitor really pushes into our area down south. So we have to understand that this could possibly higher the price than what we estimate in the beginning of the scenario analysis case. So perhaps we should think about investing more north. So these things is really important, like thinking about when you set up these sort of modeling, and that's the power of the optimization and decision support tools as we go along. So we can see sort of, we can create these sort of aspects of this is my catchment area when I take into account competitiveness, and I can sort of have my train model where we can see in the south where I use a terminal that delivers to my mill. So we can really take that into account. And another example, I think, which is a good thing that we can showcase the power of sort of the casing, where we can create different scenarios and different cases as we go along, is really looking at, we have this typical, we have an area, a circle around. Yeah, well, if we set our demand, we can see we're keeping in within this circle of the demand. So we can find sort of what's the potential, what's the volume, and I can create my map. But what happens if I higher my demand? So do I have a limit in cost? So if I go with a much higher demand, it might not be sort of beneficial that I just grow my catchment area direct with trucks. I can really see how am I affected by sort of, how can I utilize terminals and trains, and what's those catchment areas, and what would happen if I add sort of the import by ship as well. So I can really sort of do the scenario analysis and due diligence as we go along with these kind of tools. And it's really understanding sort of, we need to build that robust importance in the business case. We really need to find what are the available modes, and as long as we can define them, we can really utilize them and analyze and evaluate them with these kind of decision support tools and optimizations. So lastly, before I sort of rounding everything up, I just wanted to point out that for now, we've been talking a lot with focus on FlexSNG, which is more a strategical. We want to build or invest in a sort of this project. What would be the cost? What would be the potential? What's the feedstock availability? Which is great to sort of focus when you're investing. But what we have to take into account, what we had to make sure, is that we also start planning for, yes, so when we've invested in that, how do we actually handle the operative and the tactical part? Like, how do we actually follow up with our plan? The importance of going downstream, sort of understanding you can use decision support tools and optimization to actually continuously improve downwards as well, doing that operative and tactical level, because that becomes so important in realizing your strategical plan from the beginning. So having that downwards plan and understanding this is important to set up as well. And this is just a showcase of, this could be a strategical overview of some of my catchment areas, but this could be my real execution plan, where I see these are the routings, these are sort of the utilization of roads, these would be the real costs of doing the transportation, and sort of understanding where do I utilize what resources, instead of just looking at it from a strategical point of view. So I think that's sort of rounding everything up. And as Anders mentioned, we have that feedstock evaluation and quality and value, which we really need to deep dive in and see what's the attribute, what's the quality, what's the moisture count, what's sort of the availability throughout the seasons, and geography wise. I mean, it's different looking at just Europe. We have different conditions, we have different feedstock that are available. We have to take that into account. And of course, it's also sort of understanding the importance of setting this value chain up, this supply chain perspective in a new biomass project. We cannot just say we have a buying price. We have to sort of see it. We have to realize that we have to create this digital twin, as I mentioned earlier, to understand where are the values, where are the costs, and how do we actually execute these kind of long-term strategical plans as well, from a logistics point of view, not only buying by dry ton direct in our business cases. We have to create better business cases to understand the scenarios. And it's really to consider that end-to-end value chain as well, because when we've finished sort of the feedstock part, we have to actually sell the products. We have to take that into account as well. We've been focusing quite a lot about the feedstock and sort of the supply chain within to the biorefinery, but we have to think about sort of what's the end, what's coming after the biorefinery. How do we set that logistics up as well? Because that's quite important as a part of the projects. And of course, the importance of sort of keeping an eye on this quality and additional information about the feedstock that sort of can tailor different value chains case by case. Sort of, how do we use forest residues? How do we use agri waste? How do we use municipality solid waste? What happens if we combine them? What happens having that scenario analysis thinking, that questioning what would happen if we do this or this or this adaptability is so important when looking at these kind of decisions overall, and utilizing decision support systems as we go along. And then, of course, as Anders mentioned, the co-handle and the co-planning of different assortment is such a big part of logistics, and will become a much bigger part of the logistics as we look at more of the CO2 reductions, utilizing more harvesting equipment for larger areas with less people utilizing them, or as well as truck fleets becoming more broadened. We have to utilize those resources much better. So the co-collaboration and co-handle and co-planning with different assortments will become such a big important part of the sort of the transition into a more bioeconomy part of the the aspect overall in all of the value chains, including the bioenergy one. So that's sort of my summary and sort of my closing remarks for this presentation. Thank you.
Thank you, Erik and Anders. That was a really interesting, informative presentation, jam-packed with information. So we have a couple of questions. I have a couple of questions myself. But we'll start with the audience. So we have Marie-Laurie here. She's also one of our project partners. So hello there. She's asking, does your tool integrate other criteria? For example, in this case, she says other criteria other than cost and price. For example, is there a function where you can see about the environmental impact of the biomass collection and supply, for example?
So it's a great question, because I think it will become a much bigger part of what we're seeing as well. I think for now, the optimization model that we've started thinking about this as well from an environmental impact. But what we've started with is sort of, you can optimize, instead of optimizing against cost, we can optimize it by lowering CO2 emissions by utilizing different kind of transportation modes. So we don't have exactly the impact on this harvesting site for this assortment, but we sort of have the overall idea of lowering the environmental impact for the value chain. And of course, there are ways of combining this in together and seeing, this would be the harvest site, this would be the impact as well. But it's more focused on a value chain perspective, supply chain.
Okay.
I can add upon that as well. In another EU project, we have, at least in a research tool, we have an optimized catchment area calculation, but we also have integrated life cycle assessment. So you get this geographical component to your life cycle assessment when you integrate those two tools. So we have tested that in another EU project, but that is just research-wise. It's not commercial tools.
Yeah, I imagine it will become even more of a requirement as time goes on with these things. But yeah, I can understand how you're saying it's more of an offsetting tool, not an offsetting tool, but you can understand the impact as an offsetting instead of the actual impact itself. Great, thank you. So there's another question here from Zinzi Zhang. Thank you for your presentation. Have you done empirical study via techno-economic assessment of any of the models? And also, he wants to know, have you tested if the quantity of the feedstock is enough to support commercial bio-based production? So the first one is about techno-economic assessment.
And the answer would be that we're doing that within the project, so that's not summarized and finished yet, but we're doing that kind of techno-economic structure with the model as well within the projects. But what we've done is that we've done these kind of sort of larger perspective projects as well, which is more commercial use. So we have seen use of these sort of the model and in this regard Woodflow and Bioflow as a tool to sort of combine and overview and see different kind of business cases, setting it up. I think that brings into the second question, which was, is the quantity enough? Because that's a question which is very commonly asked within the industry. If I do this investment, can I make sure that I have the available feedstock? And the answer is, I guess, perhaps more tricky than for me to answer, but what we've seen is that when we combine these different kind of sources, so let's say we do a forest residue project in the north of Sweden, we can see that not one player has enough forest residue, but if you combine different players within the north, you sort of can combine different kind of feedstocks, and you can see that you have enough quantities as well as securing through perhaps imports or having other co-streams that feed into it. So we can see and test and verify that there is enough. And we've seen in a few cases that we do have enough for these kind of projects, depending on the size, of course, because they can scale. And if as they grow bigger, of course, it becomes harder to find all of the feedstock.
Great, excellent. Thanks for that. Now we've got lots of questions coming in, so skip to the next one. Again, Marie-Laurie, hello again. She's wondering how you deal with the problem of moisture content of the biomass during the operational phase. Do you use model or measurement on sites? How do you deal with the inhomogeneity?
So maybe Anders can start with sort of
that. It's tricky. You don't have the exact answer, even though you can do forecast models, you can work with weather data and all of that. You really have individual patterns as well. You can have expectation from an area at a specific time, but in reality, it also, the local conditions really affect the outcome of the moisture content. But on average, you can say something that can help you tailor your supply, but you can't promise any exact answers at any given site. But the general pattern can also help design your supply system.
I think that's a great answer that Anders is saying. I mean, I think that the most commonly example that I use is really describing this difficulty is that you can either have the pile in the sun or it can be overshadowed by a forest. And that sort of changes everything. But it has nothing to do with geography in Sweden. It has with the placement of the actual pile and if it's in the shadow. And that's the dilemma when we go down to a very operative level. Seeing that. But I think that, as Anders mentioned, that you can use these kind of sort of overall sort of data sets, and they're becoming better and better. So you can gain an overall understanding of how the soil moisture changes over seasons and how we can take that into account when we should utilize it and not.
Yeah, there's going to be lots of variables in this situation, as you say, at an operative level that you won't be able to control. So, which brings us quite nicely onto the next question from Henry, who says, again, thank you very much for an interesting presentation. He says, with all possible parameters and options, how robust is an optimization result? What do you have any experience of really how robust your results are?
So I would say they're very robust in the sense, I mean, Woodflow, the tool we're using in the project, well, Woodflow/BioFlow, which would be the sort of the specifics for this project. But Woodflow is used by the majority of the Swedish forestry companies doing these kind of questions, doing the strategical planning, tactical planning, down to operative planning. So we know that it's very robust in the sense that we have to just sort of describe the model, well, not the model itself, because the model is already existing. So we have to just find this kind of data that we need for the project. For the modeling aspect, I'd be glad to talk about that for hours, but just to describe it very rapidly is that instead of having these kind of normal, well, typical optimization models, which would run quite a long time for hours, we've done our own modeling language, which means that we can run this in seconds, which means that we can change and adapt and see these kind of scenarios very quickly without changing, well, with changing the data sets, we can see the changes and sort of adapt and see the flexible results very quickly instead of having to wait for 6 or 5 hours for one run to do. So I think that's a very competitive thing with our tool Woodflow in this regard as to the robustness.
Great. That kind of brings us on to the next question as well. Sadaf Abbas is asking which software you're using and if it's open source.
So we're using Woodflow, which is a commercial software within the project that we've created from Creative Optimization. So it is a commercial tool. We've had deals with using Woodflow in research. So there is the possibility of using Woodflow within research. So the best way would be just to reach out to me. We perhaps could set up a link, Emma, afterwards if somebody wants to know more about it. But there are opportunities. It's not open sourced, but we do have different kind of deals with research and sort of educational purposes. It is being used in SLU, which is the Swedish agriculture here in Sweden, as well as the Finnish university in Helsinki for these kind of problems. And I do know that some researchers use wood flow as well.
Great, excellent. I've just got a couple of questions actually. I just was wondering how easily it would be to export this tool to use in different countries. I noticed that it's quite maybe North European specific at the moment. Have you thought about how we could export it to a different country in Europe?
Yes, we've thought about that, and it is easier as you go along. We've learned a lot in this project, so it's about setting up the road network, because that's what's the power of finding, the right distances and finding the right costs. So for now, we've set up Scandinavia, we've set up Canada, we've set up New Zealand, we're setting up Crete, we're setting up part of Greece, we're setting up parts of Italy. So it is easy, and we're doing it by the country and sort of by the question of actually setting it up. So if you are interested, we can take the time to set it up. It's just that we've started with these companies or countries because we know that they are in need of it. But it is easier than you would think to set it up in different countries. And the tool was designed to work in a flexible attribute with different kind of feedstocks to begin with. So it's sort of the lowest, the barrier. You would think it's a limited to the Scandinavia, but it is being able to be used in different countries as well, as efficiently as in Sweden.
Great.
And to add on that, of course, it's developed for the Nordic situation, but you can also work with different level of aggregation in data. It's quite demanding if you want a high level of aggregation, but if you lack data, you can also work with a more coarser data set and work with a different aggregation level. So it's also a possibility.
Yeah, brilliant. That's good to know. Because of course in Europe, the variation from the north and south is quite huge. So there could be different types of information. Brilliant. And we've actually got more questions coming in, but we're running out of time dramatically. So I'll just pop to this. Stavrola has asked about, are the wood wastes you use non-hazardous? If so, where can you find this data? Do you take into account the percentage of wood waste used for new construction?
There are a database in the EU that have different quality characteristics of quite many bio-based streams. So I guess that will be the place to look different databases for describing the characteristics.
Good, excellent. We just have time for the last one. So if anybody else asks a question, it will be answered by written. But this one again from Sin Sayon. He's saying he would like to know, how do you see the trade-off between the biomass we extract and reuse from the residues and the pollution and the environmental impact, the pollution caused, especially from the transport during the bio-based production? So again, it's back to the life cycle assessment, I guess, this. So have you had any thoughts on this at the moment?
So if I begin, in the tool currently, we do not have the life cycle assessment of sort of the benefits of utilizing different kind of biomass streams from an environmental perspective if you look at the GHG equivalents. So we do take into account the transportation. So you could, by using the tool, you could actually calculate it, because you can do the trade-off, because you can see what would be my transportation cost using only trucks. If I add trains, and if I use more and more trains, how will that affect the sort of the CO2 equivalents to the biomass that I take out? The tool itself doesn't do the calculus and showcase it, but you can do an easy sort of quick math afterwards, utilizing the results to sort of calculate that kind of trade-off between them. But we don't have a life cycle assessment in this part.
Okay, good. But I think if you're following, so all our viewers, if you're following the project, the FlexSNG project, by the end of the project, which is finishing at the end of this year, there should be more information on life cycle analysis and such information. So I'd just like to say thank you again to our fantastic presenters, and I'd like to invite you all to register for the next webinar, which will be on the whole flexible gasification process, which would be the main presenters would be Sanna and Ilka from VTT, with a guest presenter, Shiri from Sumitomo. So we look forward to seeing you there at the next one, and which is in just 2 weeks' time. So be quick to register for that. And I'd like to again say thank you. Thank you, Anders. Thank you, Erik. And thank you to the audience.
Thank you, everyone.
So
Thank you.
bye then.
Bye-bye.